Alright, now we're going to turn our STL into G-code, and this is the file that we're going to put on the printer and it's going to read and actually make our part from. But what is G-code? Put simply, it's just a text file with a whole bunch of instructions in G-code language for the printer to follow. It contains instructions such as heat the bed to this temperature, heat the nozzle to this temperature, extrude the filament at this rate, and move the head to here, move the head to here, move the head to here. You string maybe a few 10,000 to a few million of these lines together, and you can give your printer a detailed roadmap of exactly how to make that part. And this is what the slicing process is. It's turning our STL with its three-dimensional geometry into actual G-code commands for the printer to follow. So here we are inside a Prusa slicer. Now I've just got this set up for a default Mark III printer. First we're going to find our STL and just drop and drag it into our slicer. Now this is a preview of our part on a virtual print bed. Left click to rotate, right click to pan, and scroll to zoom. We can orientate it how we want by selecting the part. Then we can move it with this tool here to where we want on the bed. For now, we're just going to keep it in the middle because that's perfectly fine. Now this part was designed to be printed this way. So we're going to select this handy tool here, which puts a selected face on the bottom. This is a really handy tool and it's good to remember this one. For print settings, we're just going to leave it on 0.2mm speed preset. Select PETG, as this is what we'll be printing with. You can select the brand of filament you're using, if not, just pick the default generic one. Ensure that we have the correct printer model selected here, Mark III, we've only got one set up. Now this part needs supports, as the printer can't magically print just in midair here. It needs something to build upon. So we're going to tell the slicer to generate these under supports, and then we're just going to hit everywhere. In the bottom right here, let's hit slice now. And as the button suggests, we are going to slice our STL, and this will now give us a new preview. And in nearly an instant, our STL has been converted into G-code. But looking at these commands would not be very helpful. So this preview we're looking at now is what it will look like after the printer has followed all of these G-code commands. So if we scroll in here for a sec, we can actually see that our preview now has print lines and all, as if it were the real part. Now this is where it gets really cool. If we drag this slider here on the right, we can see a cross-section of the layers that the printer will make to build up our object. And we can see that it's not solid, but a thin shell with this supporting infill structure. Similarly, on the bottom here, we can drag this slider to reveal how it's going to make this layer with a single line of plastic. And this window is a preview of the G-code commands that the printer will be following. Have a play around with this because it's pretty cool to see how the printer is actually going to build up your part. You may have also noticed the support structure that was generated. This wasn't in our STL, but Prusa Slicer calculated that the printer cannot print in midair like this, and so it auto-generated these for us. In the bottom right here, we have some stats such as how much filament is going to be used, an estimate of the cost, an estimate of print times, all very handy information. The final step, we're going to hit export G-code in the bottom right here and save our G-code to where we want. You don't have to do this part, but you can open up our G-code in a text editor. And here we can see that we now have many lines of machine instructions. Now there is a ton more settings you can play around with behind the scenes, but we're not going to touch them now because if you don't know what you're doing, you can do more harm than good. But the settings we've gone through are great if you're just getting started out, and they should be good enough to print the majority of parts that you need.